The work of this foundation was a complete surprise to Eric Simon because Fay hatched this evil scheme behind their backs and sprung it on them as a surprise. And I can't think of a more productive surprise that one could prepare than a foundation which has this mission. As Dr. Simon said, many of the foundations that you hear of and that you know about are specific to an individual disease. And they say, help stop something or other now. Go for the walk to cure bad breath or whatever the disease is. But the problem with that is that these are not information-based programs. These are programs by which to attract money, to try to attract research, to attract money to help support research, and they do good. Without them, we would be in a lot of trouble. Think of the March of Dimes and how many years of tremendous effort they have made for so many diseases, starting with polio back in the 1940s. And I remember as a child, because I'm 200 years old, I remember polio being a serious scourge among children my own age who were horribly crippled by it, if in fact they survived. So I think it's very important to realize, as Dr. Simon pointed out, that targeted research, basic research, not clinical trials, but basic research gives the information by which you then have tools that you can develop to use in clinical treatment. That's the only way it works. I'd like to give you a little bit of background on a couple of our previous fellows to show you that, in fact, what we're doing is not just providing a summer camp experience to make a happier child. First of all, many of the people that we are supporting as fellows are more experienced sometimes, I think, than we who are giving the awards. That is to say that we read their application. It is so well organized, and these people have already published, and they're not even out of undergraduate school yet. It's amazing. And they have gone out, and they have found mentorships that have productive and very, very, very strong world-class research, and are looking at the details of different mechanisms. Joanne Wong, who is with us today, is an example of this, and her work that she will be doing this summer is just an extension of her abilities in physics and math and many other areas of scientific skill that she has developed, and she has not yet graduated. Well, she will in a couple of weeks, right? Beyond that, I would like to point out that she's going to be doing work on vestibular migraine, as Faye said. This work really is a serious affliction to many people, and yet the mechanisms of it are escaping us all. It requires this kind of basic research, attention to the physics and to the chemistry and to the mechanisms by which this is set in motion in some people, but not in others. One of our fellows last year worked at the University of Michigan under a long-term friend of Dr. Simon and myself, Dr. Huda Akil, at the University of Michigan. This work is based in part on the idea that not everybody responds to everything the same way. You know that, I know that, and yet when you think about medical models, it doesn't always come to mind. But think about it. With the work that Joanne Wong will be doing, Some people are tilted in a certain angle and they go through an extremely excruciating episode of dizziness that lasts for hours. It's incapacitating. And yet you or I would go through the same tilt and say, gee, that was kind of fun, a little exciting. Maybe I'll try it again sometime. I'll actually pay money to go on that ride. We don't get incapacitated by it. What is the difference? The University of Michigan work is studying just that. They are studying individuals who respond differently to different kinds of stimulation. And they are taking examples from animal models where they can actually see the proneness to depression, to obesity, and other things that are the result of differences in metabolism in specific areas of the brain that respond in the opposite way in one type of personality and in another way is a different personality in people with roughly the same genetic background. This is going to make a huge difference. And the work is very, very productive. Our fellow, Kate Dickwitz, is a very productive fellow. She is going on, she has not yet graduated. She has another year at Michigan. She has graduated on, she now has a total of 4 publications coming out in the medical literature with Dr. Akil. And she will be dedicating herself as a result of her experience to an academic pursuit of basic research. This is the goal of the Irene and Eric Simon Foundation. Get people to become engaged enough in real and solid research that makes a difference in people's lives so that you want to continue in that direction for the rest of your career. And that's successful in the awards that we have given to date. A second fellow is going, you'll have to take notes on this because when I finish describing it in a couple of sentences, there's going to be a quiz. The research is at UCLA. The fellow is David Foulad, and the research is on glioblastoma tumor in brain. Now, glioblastoma is a death sentence. If you are diagnosed with glioblastoma because you're slurring your speech and they've done some diagnostic workup and they find it, you know that you are going to be dead within 12 to 14 months at the best. How do you treat something that is that devastating? It grows like wildfire. It encroaches on all different areas of the brain. The work at UCLA is, and that David Foulad has been integrally involved in. I spoke to his mentor, Maria Castro, a few days ago, and she said he has been a significant contributor to this work. Here's the work. Take a glioblastoma tumor sample from a patient, use it as an example in a rabbit model to generate a vaccine so that you have the ability to stimulate antibodies against your own tumor. Create a vaccine against your own tumor that you are now given that stimulates your immune system to attack and kill your own specific tumor. Now, I will tell you there are 3 or 4 groups in the world who are all running to first base on this theme. And some of them are in clinical trials now. But our team wins. What do we do that's different? What they've done that's different is they have added a virus shell to a particular receptor that the glioblastoma tumor cells express in high quantity, but normal cells do not. They have now used this to generate a second vaccine that attacks that specific cell. Now, they have added to that an antiviral drug called ganciclovir, which is a very effective drug to block any cells that rapidly divide. Combining the vaccine, the adenovirus vector, and the ganciclovir, they have produced a tumor program that they can apply to a patient and have complete devastation of the tumor. This is not radiation. This is not chemotherapy. Your hair doesn't fall out. And this is not snake oil. It's real. But there's a better message. There's something else that no other cancer program has. And this is what our fellow has worked on. And that is that when the tumor cells are dying, they release an unusual protein called HNGB1 that is not released by normal cells ever. And as a result, if you measure the HNGB1 protein release in the patient you are treating, you have an exact measure of the degree of success of the treatment at that time. That's unheard of. Usually, you get put on the drug, they try it for a few weeks, and then they redo an MRI or a CT scan to see whether or not there is some shrinkage in the gross structure of the tumor. In this particular case, they are now able, because of the work that our fellow did with Maria Castro and Lowenstein at UCLA and Cedars-Sinai Hospital, they have the ability to target a specific aspect of the tumor cell, make a vaccine against it, and as your immune system is now instructing the destruction of the individual cells in that tumor, you're actually able to measure the degree to which that tumor is being destroyed as it's being destroyed. That kind of quality control is unheard of in medicine. And this, I think, is the kind of thing that we like to hear in Irene and Eric Simon Foundation. This is the kind of thing we like to stimulate, because the people that we have encouraged through awards have continued to dedicate their lives, almost every single individual, to dedicate their lives to bettering our welfare through their research. David Foulad has applied to UCLA School of Medicine, and among the 3,000 or 4,000 applicants, they could only accept 100. He was accepted. He is now in medical school at UCLA. He is still working on this project during the summer, and he is continuing because we stimulated him to do that. Your contributions, your little things here at these silent auction, your little gifts here at the desk, your little raffle tickets, your checks that help us to do that work do not go to pay some kind of huge hierarchical structure. They don't pay for secretaries. They don't pay for car expenses and traveling and enjoying meetings. They pay for these young people to stimulate them to dedicate their lives to the benefit of our production, our health, our lives, and our betterment through medical treatment. Thank you.